Okay, so let's begin. We're talking about identification of ions. What that means, how can I identify cations and anions, generally speaking. Yeah? Yeah? Yes, Arisha, you were saying something? Why, you can't hear me? Can you hear me? Yeah? Yes, you can. Was that low? What's that? Okay. I'm confused right now. I guess I shouldn't be. All right. Now, so the principle the identification works on is on the principle of precipitation. You want to create a precipitate. What do you mean by precipitate? Basically, it's a solid forming on mixing two aqueous solutions. Two solutions. The solid is definitely insoluble, that's why it forms. So solid is an insoluble compound, generally speaking. It's an insoluble compound, and basically the idea is simply that what you do is you take, let's say, a soluble compound 1 and a soluble compound 2, and makes the precipitate of compound 3 and most likely a soluble compound 4. That's how this works. And generally it works by the exchange of ions. What that means is, maybe if your compound 1 is cation of the first molecule and anion of the first molecule, an ionic compound is mixed with an ionic compound number 2 with his cation number 2 and anion number 2. And sometimes these guys can exchange their ions, meaning that cation number 1 can now be combined with anion number 2 plus cation number 2 with the anion number 1. So you see the compound 1 was yellow, compound 2 was orange, and they've exchanged their ions. And the principle of precipitation is simply this, that one of these two compounds is insoluble. So either the one I'm highlighting blue or the one I'm highlighting in white, one of these two is insoluble, and that creates a precipitate. And that's how we identify, because we know of some precipitates. I'll give you an example. The only way to test for barium is by the knowledge that barium sulfate is an insoluble white compound. Let's say I have this information. So if you know this information, what that means is, if you take barium in the form of, let's say, chloride aqueous, and you take sodium sulfate aqueous. Now barium is cation number 1 and chloride is anion number 1, and sodium is cation number 2 and sulfate is anion number 2. So when you combine this, the cation of 1 can combine with the anion of the second, and the anion of 1 with the cation of the second. So this exchange will result in things like barium sulfate and sodium chloride. Obviously you have to balance it, and there is 2 NaCl, and since we know the here solubility of compounds matters, you know that all sodium chloride is soluble, and barium, all of, so because all sodium salts are soluble, remember that all group 1 salts are soluble, but barium sulfate is an insoluble white solid, and that's the fellow we've got to talk about. That's so identification of ion works on the principle that when any cation of one with the anion of the second, or the anion of the first and the cation of the second, form the new compounds after exchange, basically you see barium is combined with the sulfate and the chloride with the sodium, so that guys combine, and one of these two is insoluble, and that is what we call a precipitate. The abbreviation of precipitate is PPT, and your job is to know which compounds form precipitates, which are insoluble, because then you can figure out which two to add. Because honestly speaking, the most important information is all nitrates are soluble in water, and all group 1 salts are soluble, all ammonium salts are soluble. Now if that's the case, then if I want to make barium sulfate, this is the same thing as you do for salt formation. Preparation of salts and identification of ions works the same principle for some of them. The two soluble compounds forming an insoluble compound. So here you want to make this. So what you do is, if you want to make this, remember, you want to take barium with any anion that's soluble like chloride or nitrate. Even barium nitrate would have worked here. And if you want sulfate, take any group 1 sulfate because they're soluble. So I took group 1 sulfate, and then the barium and the sulfate reacted. And that's what's happening in identification of ions. They're actually adding reagents, because we know that a particular reactant forms a particular precipitate with some. For example, barium sulfate is 1. Another popular one is silver chloride. You know, this is also a white insoluble solid, but that's the basis by which we will test out. We'll also do hydroxides, but that's what we're going to start off with first. Any questions so far? You guys have gone really quiet in the group, by the way. Really quiet. What's up with that, yo? Walaikum salam, Noor. By the way, nobody's going to talk about the elephant in the room. Which is what? They're very smart. I guess they're very smart. Walaikum salam. It means that when we want soluble compounds, you can use a nitrate or group 1 compounds. That's what it means. But my question is, did you guys discuss the whole paper 2 not happening? What is that story like? You guys said, yeah? Oh my God. Okay, sorry guys, little glitch. I thought I was sharing my screen all this while with the YouTube channel. Oops. And hello guys, hi. Those who are here online on Zoom. It's like a very dead crowd. Yeah, I don't know why. Okay, yeah, I know you can see my video. You can definitely see my. All right, done. Mason, all right. Anybody else? I think it's cancelled, boss. Paper is cancelled. Yeah, somehow my mics are really bad today. Yeah. So apologies for the bad mic today. It's echoing online. Paper is cancelled. Yeah, somehow my mics are really bad today. Yeah. So apologies for the bad mic today. Okay. Can you hear me now? Yeah? There's a little background hiss coming our way. I. Okay. Anyway, so let's get back here. Where was I? Mm-hmm. Now you're on those who are attempting only paper 4 will get paper 4 and paper 1, the others only paper 1. Patul, the easiest way to do is go to my channel and search past papers while asking somebody in a chat when you can use search. You know how search works, right? Yeah. Okay, so now getting on with this. So now the idea is that which anions and which cations do you test? All right. Which anions and which cations do we test? Now the anions that we test for are carbonates. What's so special about them? So everything has a special thing that makes them easy to identify. We got to test for chloride ions and iodide as the two halides from halogens, and nitrates and sulfates. Sulfates I find easier, and then nitrates. Now some of these we will use the principle of precipitation. So these three, which I will actually, which ones? These chloride, iodide and sulfate, we will use the precipitation principle to react for this. We'll use neutralization to test for sulfates, carbonates, sorry, and we will use a redox reaction to get nitrate test, because nitrates they don't form any PPTs, they have no PPTs. So to prove if you have a nitrate, you're going to have a redox reaction. Yeah? Is my voice not, is it fine now, Mason? Okay. All right, it's fine to me. Okay, so the precipitation one is easy. All you gotta do is add for chloride and iodide. You wanna use silver to precipitate, because silver chloride is white and silver iodide is yellow. This is the yellow solid and silver chloride is a white solid. So in your observations you write white PPT formed. This is the anion list, Mason. The cation list comes later. Yeah. Then for sulfates we use the barium to test for sulfates. Now this is I'm just showing you the anion. So this is the anion list. So the anion list, we're going to use these guys to test for them. And barium sulfate is also a white PPT. A yellow solid means yellow PPT. White solid means white PPT. And generally speaking, we use the nitrates versions of because we want this cation. So we tend to use nitrates. Why do we use nitrates? Because nitrates are soluble. Sorry guys, I was just coughing. For those of you watching this on YouTube, guys, this is for O-levels. I have my own A-level past paper sessions happening as a course. You can take it. It's not on YouTube. Okay? Now, again, like I was saying, this is the principle of precipitation. The principle of precipitation is you take aqueous compounds and you precipitate some well-known precipitates like silver chloride, silver iodide and barium sulfate. And you can't use it for nitrates and carbonates because all carbonates are a precipitate, so there's no point. It won't be much. So what I do is I add acids to carbonates because then they give me carbon dioxide and water. And carbon dioxide I can test for. It's a very fast evolution of gas, which the verb uses effervescence. And the gas carbon dioxide turns lime water milky. And nitrate is a +5 oxidation state. We end up reducing it to ammonia, which is a gas which turns red, damp, red, litmus paper blue. Why? Because ammonia is alkaline. So all of these are 5 of the anions you have to know. Carbonates are tested by adding acids and they form carbon dioxide, which you will see as effervescence of a gas, which forms white PPT when passed through lime water. So when you want to make a gas and you pass it through lime water, the lime water turns white. We call it a white PPT. Okay? And on the other hand, these other 3 are precipitated. Okay? And the last one is through redox reaction. So do we use a reducing agent? We use an alkaline version of aluminum as a reducing agent. We've done oxidation reduction quite a while ago. So a reducing agent like aluminum will end up reducing nitrates to ammonia gas. So therefore, if aluminum, on adding aluminum, I get ammonia gas, it means that it must have been nitrates. If I add a white PPT on adding barium, then the white PPT is barium sulfate, which means the solution must have a sulfate ion. If I add silver nitrate and I get a white PPT, it proves it's chloride. If I got a yellow PPT, it proves it's iodide. So the idea is this. So yeah, this is what you're doing. If silver nitrate aqueous is added, okay, you can have 3 conditions. You can have no PPT, white PPT, and yellow PPT. No PPT means it has no chloride, no iodide. White PPT means the white PPT was silver chloride, therefore chloride ion present. On adding silver nitrate, if I get a yellow PPT, the yellow PPT is silver iodide, therefore I can deduce that my solution anion is silver. Because generally you will be asked to test for a cation and an anion. Alright? Any questions so far? All clear? On the other hand, so this is the idea is that, okay, if barium nitrate or barium chloride aqueous is added, yeah, and you get a white PPT and you can get a no PPT. That's it. The only 2 things happen: you get a white PPT or you get no PPT. If you get a white PPT, the white PPT is barium sulfate, therefore sulfate ions present. If you get no PPT, that means there are no sulfate ions. That's what it means. Yeah. These are the precipitations. And if acid, let's say if dilute HCl or dilute HNO3 is added, you can get effervescence of a gas, effervescence of a gas. I'll spell effervescence in proper and clear legible writing. EFFER, VESCENCE. Effervescence of a gas and no gas evolved. Now if there is no gas evolved, then it definitely means no carbonate. And there's an effervescence gas, then you test for gas. Then pass gas through lime water. And because the gas is carbon dioxide, lime water will turn white. We call it milky. Yeah? Sameed, the live stream you're watching, ka title is O-Level IGCSE Chemistry. But yes, I'm doing A2 Chemistry right now. Not in O-Levels, bromide is not required, boss. This is O-Levels. Any questions? Any questions so far? All clear? Okay. All right. Now there are two more ions for IGCSE. Which are bromide and sulfide. And bromide have the same test as silver nitrate, as silver for others. So add silver nitrate, you get silver bromide, and that is in fact a cream PPT. The sulfur trioxide I'll talk about in a second. But so the same test you have for chloride and iodide, you also have for bromide. Bromide isn't in O-Levels, but it is part of IGCSE. But the same test is used. The difference is only that instead of just white and yellow, you can also get cream. White is silver chloride, yellow is silver iodide, and cream is silver bromide. On the other hand, nitrate ka test is add NaOH and aluminum solid, and in the term of foil or powder, and warm, you get a pungent gas evolved, but you won't see bubbles. But what you will do is you will bring a damp red litmus paper to it, and once the paper comes in contact with the gas, it turns blue, because the test for ammonia is that. Which is, it turns damp red litmus paper blue. Alright? Now, sulfides is not in the O-Levels, it is IGCSE, and this test is also just like carbonates. You add an acid and it evolves a gas, and a gas is a pretty strong spinning gas. And that gas is SO2, which turns acidified, because SO2 is can be oxidized, so we oxidize it. Turns acidified manganate, which is purple, turns to colorless. Sorry about my writing at the corner. Yeah. All right. Yeah. Any questions so far? Yeah. Moving on. This is the example. Take, let's say your salt is, let's say, um, Al2SO3 thrice. Has sulfide ion in it. Add acid. Whatever happens, SO2 is evolved. You will smell it. And if it's evolved, it's the only gas that gets oxidized by KMnO4. So yeah. Alright. And you got cations. And cations all the cations to test for have the same method. The cations are tested by adding hydroxide ions, and they generally make a precipitate. You've got the ones in your syllabus are aluminum, ammonium, calcium, chromium, copper, iron 2, iron 3. Yeah. And that's I'll just repeat it for both. I'll write it down for a second. Okay, where is it? Yeah, so you got a couple from group 1. You got calcium from group 2, sorry. You got a couple of amphoteric guys, aluminum and zinc. You got a couple of colored guys, which are chromium, copper, iron 2 and iron 3. These guys are colored. These are amphoteric. And these guys are, this is group 2. Okay, these are going to make colored precipitates. Chromium makes a green PPT. And where do we find OH ions? I find OH ions in alkali. So if I add alkali to chromium ions, it forms a green PPT. If I add alkali to copper, it forms a blue PPT. If iron 2 I add alkali, it also forms a green PPT. And you'll be like, how do I tell the difference? Well, it's still green. You can't. There's one way to tell it. Is that with NaOH, this guy dissolves in excess. So some dissolve in excess NaOH and some don't. NaOH excess. While iron is green PPT, insoluble. Sorry, no, iron is not green PPT, iron is red brown PPT, insoluble, and iron 2 is green PPT, insoluble in excess. Now I have a question to ask you guys. We gotta still do more of this, but I've also started my past paper sessions. Now I have a question to ask you guys. Can I stop this for a second? In fact, I forgot about the class today. I've got too many crap going on. How many of you are IGCSE versus O levels in this Zoom class, the Zoom room? Mesam is IGCSE. And how many of you are based out of Pakistan? Hmm? How many are based? How many of you are not in Pakistan? Why? Because Monday say I'll be on Noon Academy's platform. Okay. But we live stream that to YouTube also. Arisha, if you have family in Pakistan, you can use their phone number and get a code from them and then add it. That's what you could do. That's one way it works. The other is, um, um, if you can, whichever platform you can find me on, send me your email address or your whether the Noon Academy team can contact you, and then they'll help you set it up. So Monday say I'm starting past papers. Okay, I'll share a whole schedule also. I need to record a few lectures for you guys. I'm not done with you guys. So next week when things settle down, I'll record a few lectures for you guys about the remaining stuff also. So we'll start past papers and we'll keep doing the remaining things also. Okay. Paper 1 and paper 4, yeah. For O levels, so there'll be some days IGCSE, some days O levels. But the both questions benefit both because 95% of the syllabus is the same and the questions can be interchanged for either or board. Remember that. It's not like hey, one will hurt the other. And for that, like yeah, we'll divide. Some days we'll do O level, some days we'll do IGCSE. But a couple of parts ke alawa, it's all the same. Yeah, right is a very. Are you meaning that in a sarcastic way? Yeah, right, Arisha. Noor. No, I think I Noor said. Yeah, right. Anyways, okay. I was wondering if she meant it in a sarcastic way. I don't know what. Anyway, so uh, if you guys follow me, where are you guys all? Are you guys all on the teaching circle? Noon the O levels. Where can I find you all in one place? So to pass on information about what's going on. Are you all on the teaching circle Mighty Network? Well, those who are on my Instagram can tell me on the Instagram, yeah, like Arisha. But are you all on Mighty Network teaching circle? Because then I can post all the information there about the chapters and the past papers we'll do in which order, so you can sort them out that way. All right. The same information will be on the Noon Academy group of mine, and the same information will be here also. All right. I'll do all the sorting tomorrow. Okay. Got it. Awesome. All right. I'll catch you later, guys. I have a group for teaching circle where on Noon Academy or on Mighty Network, Rida. On Noon Academy, it's open to all. It's a public group. It says O levels past papers. It says IGCSE O levels past paper group. Yeah. Let me give you the link for that. This is the group. That's it. I didn't write that copy. Don't worry. Okay. Bye bye, guys. Bye.